Okay, this is part 2 of graphing factored polynomials, and in this one I'm going to cover dealing with an odd order and dealing with repeated roots. And they're going to be done in 2 separate examples. So starting out, this polynomial here has an odd order. I've got our polynomial is x minus 2 times 1 minus x times x plus 3. Now the first thing I'm going to do to better understand this is rearrange it so that I've got the x at the front of each of the factors. Notice I've got minus x at the front, and then that 1 still has to be added because it's positive here. Now I'm going to find my leading term. When each of those brackets are in order, with the highest order x term at the front, we can multiply them all together. That's going to give us the leading term. And the leading term is going to be x times negative x times x. So that's negative x cubed. So what that means is the degree of my polynomial is 3. And my leading coefficient is negative 1. Okay, so what does that mean about my end behavior? Well, if my degree is 3, that's odd. So I'm into a polynomial that looks like this, or perhaps it could look like that. The key thing I want you to remember is whenever the degree of the polynomial, that is the highest exponent, is odd, with your end behavior it extends in opposite directions at the corners. How do you tell if it's this one or that? You look at the leading coefficient. If your leading coefficient is negative, it's coming down. If your leading coefficient is positive, it's going up. So here I've got a leading coefficient that's negative. So that means that my end behavior is, it's this one. As x becomes a large positive, y becomes a large negative. As x becomes a large negative, y becomes a large positive. So my end behavior is going to be as x goes to infinity, y goes to negative infinity. Because that leading coefficient is negative, we're going this way. And as x goes to negative infinity, y goes to positive infinity. So it looks like this. Finally, my zeros. Your zeros are the point that this intersects the x-axis, so it's the point where y is equal to 0. For this to intersect the x-axis, each of those factors, one of those factors has to be equal to 0. So either x is 2, or 1, or negative 3. If that's not immediately obvious, I suggest you check out a video on solving quadratics by factoring. It'll go over in more detail how we've got that. But here, if x is 2, if it is 1, or if it's negative 3, that's going to make the whole thing 0. Finally, the y-intercept. For the y-intercept, we make x equal to 0. And we've got, if x is 0, our polynomial at 0 is going to be negative 2 times positive 1 times positive 3. That's negative 6. So now to sketch the graph with all of these characteristics, we've got a degree of 3 and a negative leading coefficient, so we have this end behavior. And we've got zeros at negative 3, 1, and 2. So that's negative 3, 1, and 2. I've got a y-intercept of negative 6. and I want to get my end behavior right. So as x goes to negative infinity, y goes to positive infinity. So it's coming down this way. And as x goes to infinity, y goes to negative infinity, so it's coming up this way. And then we've got to hit each of those zeros and our y-intercept. You're going to end up with a shape that looks like this or that whenever the degree is odd. When it's positive, if the leading coefficient's positive, it'll go this way. But if the leading coefficient's negative, it'll come down that way. Okay, I'm going to show you now a polynomial. Where we've got exponents on the brackets. To start out with, we've got to find our leading term. Now, all of the x's are in order here. I've got the x at the front of each of these brackets, and I'm going to apply the exponent to each of those and then multiply them together. So my leading term is going to be 3 times x squared times 3x cubed. Now here you got to be careful. Put brackets around that first term here, and you've got to apply that exponent to the entire term. So that's 3x, and that is all cubed. So my leading term is, I've got x to the 3, 4, 5, 6. I've got 3 cubed, which is 27, and that's multiplied by 3. So that's going to be 75, 81. 81x to the 6. Let me just verify quickly here. Yeah. Okay, so what does that mean? That means that the degree is 6, which is even. And with an even degreed polynomial, it's going to look like this or that. It'll look like this if the leading coefficient is positive. It'll look like that if the leading coefficient is negative. The leading coefficient is positive 81. So our end behavior is as x goes to infinity, y goes to infinity, and as x goes to negative infinity, y also goes to infinity. We have this. We have this situation because the degree is even and the leading coefficient is positive. Okay, we now have zeros. Our zeros are at negative 6, positive 5, and positive 2 over 3. However, notice there's an exponent here, which means we actually have 2 zeros at positive 5. So that's, I'm just putting a times 2 because we got 2 of them. And we have 3 zeros at 2 over 3. So I'm going to put times 3, just as a note. And finally, our y-intercept. And to find the y-intercept, all you've got to do is make x equal to 0. So our polynomial at 0 is going to be 3 times 6 times negative 5 squared times negative 2 cubed. So that's negative 8 times 25 times 6 and times 3. So if you multiply all of these together, you're going to get this large negative number, and that's your y-intercept. So I'm just going to write here it's a large negative. It's in the thousands. And I won't waste your time doing all of that arithmetic. Okay, so what does that look like when we have these double and triple zeros? We know that we have a positive leading coefficient and an even degree. So it's going to look something like this. We've got a bunch of zeros, but it's going to start here and it's going to end up here. That's our end behavior. Now, let me plot in the zeros carefully. Our zeros are at negative 6, 5, and 2/3. So I've got a 0 at negative 6, one over here at 5, and one over here at 2/3. So that's 2 over 3, or 0.666. However, the one at 5 is a double 0, which means it's going to bounce here. You see, if you have a double 0, if the order of that 0 is a 2 or a 4 or anything even, it's going to bounce. The 0 here, the order is 3, it's a triple 0. It's going to be an inflection point, so it's still going to cross through the axis. And then up here at negative 6, that's a single 0, so it's just going to go right through. So this polynomial here, with a 0 at negative 6, it's going to cross through at negative 6. With a double 0 at positive 5, it's going to bounce here at positive 5. And with a triple 0 at 2/3, it's going to go through. It's just going to have this sort of funny shape as it goes through. We call that an inflection point. And then again, our end behavior, we have a positive leading coefficient and an even degree. So we're going to extend to y equals positive infinity as x goes to infinity and as x goes to negative infinity. If you want to stick around, I'll do the arithmetic real quick to get the exact value of the y-intercept. Remember, the y-intercept is when our polynomial's x value is 0. So I put 0 into this polynomial. I replaced every x with a 0, which gives us this. And then we just got to do a little bit of arithmetic here. So 3 times 6 is 18, so that's 18 times 25 times negative 8. So that's 450, and I've got 450 times negative 8. Okay, so our intercept is at negative 3600, because that is the value of our polynomial when x is equal to 0. To recap here, we put all of those leading coefficients, or all those leading terms, together. We multiply them all together to find the leading term. And then we look at the exponent on the leading term. That gives us our degree. And we look at the leading coefficient. And whether it's positive or negative indicates the shape to us. And we use that for the end behavior. Then find all the zeros. You find the x value that will make each of these factors 0. If the exponent is 2, it's a double 0. If it's 3, it's a triple 0. A double 0 indicates a bounce. Think of it as a change in direction. A triple 0, it changes direction, then changes direction again. So it has this funny curve, but then it makes its way through. Here, that's just a single 0 like you're used to. So it just goes right through the x-axis there.